All right. Hello, everyone, and thank you for joining us today for our Databricks launch event featuring Tonic's native integration with Databricks, the powerful data lakehouse provider. My name is Chiara Colombi. I am the product marketing manager here at Tonic AI, and I'm happy to be joined by our co-founder and head of engineering, Adam Kamor. Hey there. Today, we're going to explore our support for Databricks and to demo the product in action to show you how we've really streamlined the challenges of data masking and tokenization in Databricks. We'll also leave plenty of time for questions, so please do feel free to ask questions. You can pop them into the Q&A function. I'll also look out for them in the chat. We always love hearing what's on your mind. So in case you're new to Tonic AI, by way of a very brief introduction, we are the fake data company. Our focus is on generating highly realistic fake data that is safe to use in software development, testing, data analytics, and data science use cases like ML model training. And the way we do that is by generating data based on existing data. With Tonic, your test data looks, feels, and behaves like production data because it's synthesized from your production data. Our platform deploys on premises, it connects natively to your production databases, and that enables you to apply transformations to that data and generate new de-identified data sets that are really sized and shaped to your developers or your analysts' needs. And as you can see, we offer native support for a broad range of databases, from popular relational databases to data warehouses to NoSQL offerings like MongoDB. We also easily integrate into your CI/CD workflows. But today we're going to focus on Databricks. We're really excited to be launching this integration because of the unique challenges that it represents and the opportunities it opens for Databricks users. Within the synthetic data space, we're currently the only provider that offers native support for Databricks. And I think this is because at Tonic, we do love a challenge. We're pioneering a secure, effective test data solution for data lakehouses. But what is this challenge I keep referencing? If you're a Databricks user, or honestly, if you're a data user, generally speaking, these details will come as no surprise. The challenge breaks down into three parts. Number one, scale. Data lakehouses are very, very large. Databricks obviously is built to work at this scale. It's one of their core value props. But what that means is that any solution you build to integrate and work with Databricks must be equipped to work at that scale. And when you're talking about de-identifying an entire lakehouse, it becomes a very weighty task. It's not easy to accomplish in-house, and it requires specific architecting on the part of vendors to build a successful solution. Number two, complexity. Arguably, all data today is complex, right? Partly because of the size of today's data, but also because of the way data is processed by our data stores. Your data in Databricks might have situations in which multiple fields are combined within a single column, or data that's been mutated in some way between its collection point and the lakehouse. All this complexity requires a really complex solution that is capable of handling all data types and scenarios. And the last part of the challenge is sensitivity. If you're using Databricks to store sensitive customer data or proprietary business information, you're going to have data in there that is almost undoubtedly subject to one of the recent data privacy regulations. And if you're planning to use that data in development or analytics, fact of the matter is you can't. You need to make sure that PII is purged from your data before it makes its way into your lower environments. So the combination of scale, complexity, and sensitivity means that securely de-identifying your data in Databricks while preserving that data's utility is not easy. So if it's so hard, why do it at all? Well, let's look at some use cases. The first and most obvious, at least from where we stand, since this use case has really been our focus at Tonic since day one, is software development and testing. A lot of Databricks users today are building their apps on their data in Databricks, which is an incredibly powerful resource for them. What we're happy to enable Databricks users to do is to build their apps safely by first de-identifying that data. When done well, your developers and QA teams get data that is as effective as production data, but purged of sensitive information and safe to use from your sandbox to your staging environments. The second and potentially less obvious use case is data lakehouse tokenization. This is the act of replacing sensitive data with non-sensitive tokens that offer no exploitable value to bad actors. But tokenized data, importantly, does still retain value for data analytics. And what it does is it enables organizations to store data long-term in a way that's not subject to those shorter timeframes imposed by privacy regulations. Both of these use cases really speak to that broader use case, which is compliance. By de-identifying or masking your data in Databricks, you're ensuring the compliance of your software development and of your data teams. You're also enabling offshore development if you need to send data overseas to offshore development teams. This is a component of compliance that we see at a lot of our customers. We even have customers running high trust environments that are made possible by de-identifying their data with Tonic. So how are we doing this? Before we jump into kind of the hands-on how-to of Adam's demo, I'd like to quickly touch on the key ways that we have built Tonic to meet the needs of Databricks users. And you'll see that these capabilities align with the challenges we outlined earlier. Scale. We have specifically architected Tonic to match the scale of any data lakehouse. This means that Tonic works unbounded on Databricks. We can move data as fast as your hardware allows, and Tonic will never be a bottleneck to that speed. The second point is complexity. Tonic is equipped to handle those complex data situations that result from how your data is processed in Databricks. Those mutations that we talked about earlier, or combined fields within a column. How your data lakehouse processes your data can affect how you need to de-identify it. So we've built targeted data generators to handle those mutations, to maintain consistency, and to ensure meaningful data in your synthesized output. And lastly, sensitivity. With features like privacy scanning, privacy reports, and a plethora of generators designed for all of your sensitive data types, Tonic gives you the tools you need to ensure that your data is protected to meet the most stringent privacy standards and certifications. All this said, don't take just my word for it. Let's see it in action. Quick reminder, like I said earlier, we love your questions. Do drop those in the Q&A. I'll try to ask them of Adam as they come up in case they're related to what he's showing you specifically on the screen. And we'll also leave time for questions at the end. With that, I'm happy to pass the mic over to the man behind the magic, our head of engineering, Adam Kamor.
Hey, thank you, Chiara. That was a great introduction to Tonic and Databricks. So, hey everyone, like Chiara said, my name is Adam. I'm on the engineering team at Tonic. I'm also one of Tonic's co-founders. Before I hop into the demo, I'm going to just kind of lay the stage here. So Tonic's the fake data company. We de-identify data sets. Data sets can come in a few different forms, right? Like a really common one that we see is application databases. We de-identify your production database. You can use it in your lower environments like staging and development so that you can actually test and develop with production-like data. Databricks, sometimes our customers use Databricks as like an application style database where like some server is interacting with some front end and is querying data from Databricks to kind of, serve to customers. Other times though, and more often, Databricks is used more as a data warehouse or as a data lake house, which I think is a term that they've invented. And in those situations, the use cases for the data are a little different, right? Like it's not connected to an actual application. It's typically just used by, machine learning engineers, by data scientists, by analysts, your BI tools like Tableau and Power BI and Looker, they connect to it, right? It is a store that stores basically all of your organization's data for querying later, not necessarily for the purpose of connecting an application to. And in those situations, Tonic is really a great tool for de-identifying that entire lakehouse of data for the use cases that Chiara kind of already talked about. And the way that you do that is a bit different than if you are already using Tonic for de-identifying a Postgres application database. So, I think I can see like in the participants list right now, there's several of our current customers are here that are using Tonic for non-Databricks purposes. So, as you're going through this, feel free to ask questions, kind of comparing and contrasting when you'd use, why is this different than what we're already doing, with Tonic and Postgres or SQL Server, for example. So let's hop into that demo now. I'm going to share my screen and I'm going to do my best to share the right screen from the get-go. Share screen, that looks good. Share. All right. Chiara, am I sharing the right screen?
I see Databricks Data Lakehouse Workspace.
Yeah, great. Okay. So for many folks in the call, this is going to be their first view of Tonic. This is where we can kind of see all of the workspaces that we've created in the tool itself. A workspace is essentially a mapping of a source database to an output database. So think of Tonic as essentially sitting in the middle. It connects to the source database. It streams all the data into it, processes that data, and writes it to an output database elsewhere. Now, the architecture of how we do this, depending on the database, can be different, right? Like if we're working with a normal application database like Postgres, we literally do stream the data from the Postgres database into Tonic and then write it to an output database. Databricks, it's a little bit different, right? Because Databricks is built on top of Spark. So the way we de-identify data in Databricks is actually by just running our data transformations as Spark user-defined functions or Spark UDFs that can just run in an existing Spark program. We're not going to get into that level of detail today, but if there are questions, I'd be happy to answer them either on this call or in a later conversation. So the first thing we got to do is create a workspace. We got to tell Tonic where the Databricks cluster is, where the data is, etc. I'll show you what that looks like. Even though I've already connected to a workspace that we're going to be using, I'll give you an idea of how it works. So, I mean, there's some pretty straightforward things of, providing a name for your workspace. I might want to call it Databricks Data Lakehouse, for example. Then you got to go down and select the actual database you're connecting to. So we support a variety of different types of databases, application databases, which I've already spoken about, data warehouses, and then databases, I'm using air quotes here, databases that are kind of, backed by Spark. And we put Databricks in that list. It could, arguably also go into the above list of warehouses. So when you click on Databricks, you need to provide the Databricks database name where all of the tables you care about exist. So you put your name here. These are some very Tonic specific features that we're not going to touch on today. This one actually maybe is interesting. Oftentimes, you want to be very aware of when additional data has been added to a table or new tables have been created so that you don't accidentally begin copying sensitive information to a de-identified data lakehouse elsewhere. So by choosing this option, Tonic will actually stop data from being moved until a user has acknowledged, there's been a schema change. For example, a new column called SSN has been added to this table, something like that. As of today, we support Databricks on both AWS and Azure. We don't support it on Google Cloud at this moment, but that's only because we haven't had many requests for it yet. But if you're on Google Cloud and you're using Databricks, let us know. We'd be happy to talk. And then down here, you just provide the necessary connection information to connect to your cluster. This is very similar to the information needed for connecting to Databricks via like the JDBC driver, for those that understand what that is. So finally, you need to tell us where you want to write the output data. Tonic does not actually create a second de-identified Databricks database for you. We actually just take the data that the database references and write it to an output file system. That output file system can be in either Amazon S3 or Azure Data Lake Gen 2, and you can choose. So for today, I've already created a workspace. We can edit it and look at it very quickly. All very standard connection information. And then I'm choosing to write my data to this S3 output location here. And we're going to go there in a few minutes and check it out. So you can see that I'm writing it to a folder called de-identified warehouse. If I go over to S3, you can see we have our warehouse and we have our de-identified warehouse. So this is where the real data sits, and this is where the de-identified data is going to go. The data that we're going to be working with today is some internal data that our engineers have generated while using our application in our own staging environments. We use a tool called Amplitude for kind of tracking behavior within our application. And then as that data, as our engineers are interacting with our application in the staging environment, we're sending this event information to our own Amplitude staging environment. So we're going to be using that staging data today for this demonstration. Great. So we talked about connecting. Let's now get into the product. The first thing that happens when you connect to Databricks is we're going to scan all of the tables in a database for sensitive information. This is kind of a way to bootstrap yourself. It's going to say, hey, here's where we think all of the sensitive information is that you need to be aware of so that you can begin transforming that data, de-identifying it, tokenizing it, what have you. This can be really helpful for large data lake houses where you have a very large complex schema. Like oftentimes no one in the organization knows where all of the sensitive data is, right? Like this can be a way to kind of bootstrap yourself. Additionally, if you already have a data catalog somewhere that kind of tracks what's sensitive and what isn't, you can integrate that catalog with Tonic using our REST API. In fact, everything I do in the product today, you can do via our API as well. And our product ships with its own API documentation. I'd simply go, lost my mouse for a second. Simply go here and then click API documentation. It'll take you to the Swagger docs. So if you have a catalog, you can integrate it into Tonic. Alternatively, if you don't have a catalog, but you would kind of like one, you can use Tonic as your data catalog moving forward. Tonic will keep track of all of the columns in a table that are sensitive. And then you can programmatically export that information into other tools if you like. And we'll consider things to be sensitive that we automatically find, or things that you manually flag as sensitive as well. So there's only one table in our data warehouse. That's because this is just a kind of a simple data set just for demonstration purposes. And that table is called amplitude data. We have found 5 columns that are potentially sensitive and 44 columns which are not sensitive. And we haven't yet protected any of the columns in the table. All 5 of those sensitive columns are here in red, and all of the non-sensitive columns are in gray. So as I'm going through these, I might actually just say, you know what, event properties, I know what that column is. That's actually this non-structured JSON blob that gets sent with each individual event that gets fired off. And what's in that JSON blob is kind of a function of the event. And occasionally, it could actually have sensitive information in there. So I could simply go here, and I could click sensitive. Then we'll start tracking that as a sensitive column. So now it's in your internal Tonic data catalog. As we're doing all of these actions, we actually have an audit trail that will kind of track all of the columns and what's happening to them. It tracks things like who's made a change to the column, what the change was, when it happened. And then you can go back and look at these audit trails to see, kind of what changes have been happening over time. Okay, let's go a level deeper, because that's kind of like the 30,000-foot view of how we look at your data lakehouse. We can go to this database view. This is actually going to show us all of the tables and columns in the database. And look, for demonstrating today, we're using a very simple data lakehouse of just a single table, right? Our customers typically come to us with hundreds or thousands of tables and individual databases and 10,000s of columns, right? So this UI right here is really purpose-built for identifying and then de-identifying columns in bulk and very, very quickly. It's really designed with this idea of like, what's the minimum number of clicks that you need to kind of de-identify that database? So
we actually have a question that just came in that kind of speaks to that around automation. And the question is, how can columns be automatically identified as sensitive? Isn't that domain specific?
It is domain specific. So Tonic ships with a variety of different definitions of what's considered sensitive. And we have, depending on what we're looking for, we have different ways of kind of identifying what's sensitive. So I'll give you some examples, right? Like there are some types of sensitive information which we can just identify via lookup tables. US states, countries, ISO codes related to countries, things like that, right? There are other types of PII that we can identify via regex. Email's a really good one. It'd be very difficult to identify every single valid email address out there as regex, but regex in general does a very good job of identifying email addresses. And then things can get more complicated. For example, our PII detection around names it involves combinations of machine learning models and lookup tables. So it runs the gamut from pretty easy and trivial to pretty complex. And we're always adding new types of PII. So if you're concerned that Tonic doesn't kind of identify the types of PII you're looking for, we can typically add new PII detectors very easily, and we're constantly adding to that list.
Thank you. That's great.
Sure. Great. Okay. So let's start kind of looking through our data lakehouse to understand what's going on. So, okay, these are all of the columns. The ones in red are what we've already flagged as sensitive. I can actually get down to just that list by clicking on this filter and filtering down to just the sensitive columns, right? And I can see, okay, there's city, event properties. That's the one I manually flagged. IP address, language, region, user ID. That seems like a reasonable list. Maybe there's other things we've missed. Let's just get a really quick idea of what user ID is. Because if it's a GUID, I would kind of disagree. But, okay, these are actually email addresses. So yeah, I think user ID is sensitive. And this is actually a really good example of how we identify emails as sensitive automatically. We're not doing that by just looking at the names of the columns, which is a technique we do use for some PII types. We're actually looking at values within the column to identify what's sensitive. So here we find some emails. And I'll remind everyone, we're working with data that we generate in our own staging environments. So the data is going to all be very Tonic specific. And that's just because we're not going to demo with, obviously real sensitive data here. This is all, staging, not super important data that we're going to be working with today. But I hope that doesn't detract from the demo. So now we got to start de-identifying this data. We can do it from this view, or we can go down a level deeper into the product and we can actually look at the data and understand what we'd like to do. So let's let that view load. And we can start doing that. Great. Okay, so here's kind of a preview of what the data looks like. Okay, very nice. I'm just kind of scrolling through it. Looks reasonable. Again, the column headers that are red are the ones that are sensitive that we want to address immediately. So we start off with these cities. There's a lot of Washingtons, and then there's some Atlanta, Chicago, Reading, I'm not sure where that is, etc. All right, so we can de-identify cities in a lot of different ways. Some are more appropriate for data lake houses than others. So I'm going to show you one way we can de-identify cities, which is not good. I'm just going to apply a city generator. This generates random cities. So for example, if you were trying to understand the number of events by city, applying this transformation completely screws up, the results that you would like to compute on your de-identified data lakehouse. Because remember, the goal here is we want to take our data lake, we want to de-identify it, so we have basically a copy of it, but the data is de-identified, and we can still do certain types of analysis and model training on that data. And if I apply that transformation, everything's borked, right? That query of, select count star comma city from table group by city, that no longer works, right? So we can improve it a little bit, okay? Well, instead of using just a random city generator, let's make it consistent. Consistency guarantees that a given input city will always go to the same fake output city. So if you remember in the original data set, it was all Washingtons here. Well, Washington is now always Olive Branch. Okay, that's reasonable. Down here, we have a cluster of Houstons and then some Los Angeles. Well, those were originally San Francisco's. And then see this cluster of Chicago's and then a Chicago up there. The Chicago's are now Los Angeles. Okay, so consistency actually it's pretty good, right? Like if we were to do that same query where we count the number of events per city, the counts are going to be pretty accurate, but the cities are all now kind of random. Maybe that's sufficient for what you're trying to do, and maybe it's not, but it's definitely better than what we had before. One issue though, or there's two issues. One, there's no way to ever get back what the original city was, which may be good or bad depending on exactly what you're trying to do. And two, this consistency feature does not guarantee no collisions. So yeah, it'll guarantee that Atlanta always gets mapped to Sacramento, but it won't guarantee that a different city doesn't also always get mapped to Sacramento. So there can be collisions, and if there's collisions, you could actually screw up your counts. Now, the probability of having a collision it's really complex to kind of figure out, but you can come up with upper and lower bounds. And depending on the type of data you have and the type of consistent generator you're applying, you can oftentimes actually get away with just using consistent generators because the collision rates are going to be very, very low, below the threshold at which you'd care for, whatever type of analysis you're doing. So that's one option you have. I'm going to leave it as a consistent city generator for now. And then we're going to move on and I'll show you some other options we have on these other columns. I'm going to skip event properties for a second. This is a very tricky column. We're going to come back to it though. All right, let's do IP address. This is a good one. Let's go to the top. So these are all the IP addresses from a user. And then cool, we got some others here. Now, one option I have is to apply a character scramble. A character scramble takes every character and it converts it to a random character, but it keeps the characters in the same class and it leaves punctuation unchanged. So, all these digits get replaced with random digits, but since the period is punctuation, it stays the same. Okay, well, we have the same issue where everything's kind of random and you kind of lose any statistical properties you might care about. Well, I could make it consistent. Okay, these aren't going to be always valid IP addresses, but the benefits of consistency that we talked about earlier will work. If we don't like that, we can also use an actual, do we have that available here? We can actually use an IP address generator. That'll generate correct IP addresses, ones that are actually valid, and I can make it, again, consistent. Okay, that's reasonable. But we still have this collision issue. So one other thing we can do, and I'm going to use this a few other times. We have a subset of our generators actually guarantee no collisions. They'll guarantee uniqueness. So they'll guarantee that a given input value always goes to the same output value and that two different inputs don't get the same output. So that is a better way of preserving the statistics that you care about. But there are, of course, trade-offs. One is computationally, it's hard to do and it takes time. Additionally, the output of this generator isn't going to look like the input all the time. So for example, for the IP address, these obviously don't look like IP addresses anymore. These are actually just tokens back to the IP address. Typically, these tokens are length preserving, where if the input was, a 32-bit integer, the token will also be 32 bits, for example. So you can use these on fixed width columns. I know IP address isn't a good example because it's not actually a fixed width column, but these types of generators that we have that have these properties will fit into fixed width columns. So you can apply them on really any data type, either variable or fixed width. So now we have these tokens. So, this is one of these tokenization generators that you can use throughout your data set. I'm going to leave that because I think it's appropriate here. Language is interesting. Essentially, every value in this column is going to be English because all of the Tonic engineering team has English as their language. And if that's not entirely true, it's at least 99%. So what do we do here? Well, we can certainly de-identify it, right? I mean, I could, for example, use, I guess we'll just do a character scramble and we'll make it consistent, right? That's one thing we can do. If we don't like that, again, we can use the ASCII key generator. Great. In either situation, though, someone that gets access to that de-identified data lake is going to understand that, okay, well, English is likely the majority in this column. Therefore, I just find the token that appears most frequently, and I can map that to English. Now, that might be acceptable, though, right? For a few reasons. One, if every row has the value of English isn't really a sensitive value that we need to care about. What we could possibly care about are the one or two example rows where it's not English, right? Because those can be more identifying of individuals. Rare events lead to, worse privacy outcomes. In those situations, knowing that this token goes to English does not help you know that this other token goes to Spanish, for example, or some other language. So these tokens can still help with privacy on those more rare events. But again, there's caveats that you have to think through here. Great. Let's keep going through this list. Region. A lot of options here. I think this is, let's see what this is analogous to. So most of the time, this is just state. That's interesting. We have options here. I think, depending on the analysis you want to do, you can use one of our tokenization generators. You could use one of our consistent generators. But let's not ever rule out, our safest generator. Just make it null, right? For columns that you actually don't care about the values, nulling them out is, the safest thing you can do. There's no way you're going to get a privacy leak that way. Of course, you need to make sure it's not being used in your analytics. Okay, we're going to keep going through. We have one other thing, user ID. I'm going to use an email generator here, and I'm going to make it consistent. I think that's interesting. What that does is create valid-looking email addresses, meaning, it's got something to the left and to the right of the @ and it has a domain. It's a 2-letter domain because the original values are all .ai. So, it's preserving the length of the top-level domain. If I want to, I could go in here and force all emails to end in tonic.ai if I just wanted to preserve what was to the left. But I'm not sure that's necessary for, the use in a data lake house. So we're going to leave it as is. This would be another really good example, though, of when you could also use one of our tokenization generators if that's what you felt like you needed. Excellent. Okay. So obviously, we could go through this table with a finer tooth comb, identifying additional pieces of information that we feel need to be de-identified. Timestamps are always a really good example of that. How do you safely de-identify timestamps while still preserving, the analytics that you care about? For example, maybe you're trying to do a study on, okay, well, what's the time delta between receive time and upload time? Well, we have a lot of solutions for de-identifying, either individual timestamp columns or groups of timestamp columns to preserve, relationships like inter-arrival times or, the time deltas between columns. I'm not going to get into those today, but there's a lot we can do there to help preserve analytics. Very good. Okay, so, well, we've done all this. Now what do we do? Well, before the webinar today, I actually did something. I went and I actually already clicked generate data, meaning I copied my source data set to the output while de-identifying it. Let me show you very quickly what that looks like. Well, here's my warehouse. Let's remove that filter. My warehouse is partitioned by this DT column. And you can see DT, it'll probably appear, yep, right here. DT and company are both actually my partitioned columns. So I can go here, and it's partitioned by day. Second, it's partitioned by company. Why did I do it this way? Because that's a really common way our customers do things. They like to partition the incoming data to their data lake by day. And that's really great for Tonic, and I'll explain why. When we start working with customers on Databricks, there's two challenges. Challenge one is de-identify all of the data in the data lake prior to us, purchasing Tonic, right? It could be, and this is no exaggeration, with some of our larger customers, that can be petabytes of data that need to be dealt with and processed. So first thing we do is that big bang. We copy petabytes of data from the data lake to the de-identified data lake, right? From the red zone to the blue zone, let's call it, okay? Okay, well, we've done that, great. But then tomorrow comes, and over the last 24 hours, a bunch of new data has been added to the real data lake. Well, what do we do about that? Well, one option we have is we could go delete the de-identified data lake and copy all the data over again. But you obviously don't want to be in a situation where you're copying the same, 99% the same, like 10 petabytes of data every day. That would really possibly not fit into 24 hours, A, and B, it would be insanely expensive. So what you really want to do is you want to have data sets that are partitioned by date. You want to do your big bang, you copy everything that, you want to copy everything over on day one. And then on day two, you're just copying the previous day's partitions. And then in that way, you're really just copying the delta every day, which is much more efficient and very quick. So this data goes back about a year. If I go to DT equals 2022 dash, actually, no, I'm sorry. This is the source data. Let's go here. Let's now go to the de-identified warehouse. Go to amplitude data. Okay, so we have the same, partitions. Tonic will preserve that partition hierarchy. You can click for a given day, and you'll get a given company. Of course, here it's all Tonic because this is, staging data. I can then, let's find, I don't know, a recent date. Okay, so we have the data from the 1st of November to the 7th. I ran this essentially 2 days ago. I ran it on the 7th, and it has not copied over the data from the 8th. Okay, well, what can we do about that? Well, I can go here, and I can actually now tell Tonic excuse me. Great. I'm going to tell Tonic to only focus on this partition where the dates column equals, yesterday, essentially, right? And I could get more fancy. I could, I'm not sure if Databricks has this functionality but if Databricks has like, a variable or a placeholder for today's date, like, current date, like it is in many other databases, you could do things like where DT equals current date -1, right? And of course, you can update this partition filter programmatically. So, if you want to run Tonic every day, just processing the previous day's data, you can set up, tasks and jobs for doing that, with very simple Python scripts or, whatever your, scripting language of choice is. So I've done this. I can now go and generate data. When I go generate that data, it's going to write over just the previous day's partition, and all of the other de-identified data will stay there. And in fact, if I go to the jobs page, I can kind of watch it. And it's running right now. I don't know if it's going to finish by the time we conclude the demo today, but if it does, we can check it out. And, this is actually running quickly. Sometimes in these clusters, there's other jobs that are queued up, and it looks like we got lucky, and maybe it'll finish pretty quick. So in addition to being able to de-identify the data lakehouse, which is, really the point of the tool is to generate, fake data, we have a lot of other nice features in the product that makes things easier for you. I'll give you. Go ahead.
We just have a question around the delta and partitioning. What if you are using delta tables and previous partitions get some updated data that may need to be de-identified?
Oh, interesting. So what you'll need to do in that situation, I'd have to ask the person, do they know which partitions have updates, or is it going to be random every time and they don't know?
Yeah, we can wait to see if
well, I'll kind of talk about it in a few different ways.
the
So
answer is they're not sure if
they're not sure. So what they're really looking for is more of like an upsert operation. That's interesting. I let me like go into like the brief details of how let me think for a second what I would do here. So the way this feature works, oh, and very quickly, the job completed. If I go to my de-identified data warehouse now, 08 is there. If I do like that, like it was before, S3 has this issue. Let me just refresh. Yeah. Sorry, 1 second. I'm not avoiding the question, I promise. And now November 8th is there. We can click in, company equals Tonic. Here's your de-identified data, a set of Parquet files. And they're Parquet files because the original data was also Parquet files. In general, we preserve the data type. Additionally, since we're about to talk about Delta tables, if you're using Delta tables, we support Delta tables natively, and we can actually go a step beyond that. A lot of our customers, they want their de-identified data lake to be in Delta format, even if the original data lake was not. And in that situation, go down here, check that format, or check that switch right there, and your de-identified data lake will all be in Delta format, regardless of what the source tables are. So that's another fun option for you. Okay, so it sounds like what the participant is asking for is like more of a standard like upsert operation. My advice to you, I'm not sure if there is like the tooling within Databricks for Tonic to tackle this within the product itself, but I said this at the beginning. The way that we interact with Spark in general, and also Databricks, is all of our data transformations are packaged up as they're packaged up as Java code and Java functions, and they're created as Spark UDFs. So when we go to actually process a table, it's just looking at your configuration in Tonic and applying the correct UDFs on the correct columns in your data frame before eventually making that call to dataframe.write, where you specify where to write down the data set. That's all that's happening. So a subset of our Spark customers, and this includes both Spark and just Databricks, actually use our Spark SDK, our Java SDK, to apply Tonic transformations on top of their already existing Spark and Databricks jobs. So it might be that that's what you would have to do. And the reason customers like to do that is sometimes they don't want to run an additional set of Databricks or Spark jobs, just for Tonic. They already have jobs that are running that are processing all of the incoming data for the day, right? It's a little silly to run a second set of jobs that are processing that same set of data. So instead what they do, they use our SDK, they go into their existing Scala program or Java program or PySpark program, and then they add a few lines of Tonic code, which will automatically read your Tonic configuration, what you specified in the UI, apply it to the data frame representing, the incoming data for that table. And then, programmatically, they can choose where to write it to. So you might need to do that because I think what you're looking for is a more generic, like upsert operation. But happy to chat further. Maybe there's another approach as well that I'm not thinking of.
I'm wondering if this other question also relates kind of to what you were saying about using the SDK and
sure.
What you think. Is there a way to export/import all the workspace configuration for automation within CI/CD pipelines?
Oh yeah, absolutely. Yes. So, and this is just a generic Tonic feature, not related to data lakehouses at all. I can export and re-import my workspace configuration here. By exporting it, I'm going to receive a JSON file. It's just going to download a JSON file, which basically has all of the options I've checked in the UI today. And by importing it, I can recreate my workspace. And of course, you can import and export programmatically as well via our REST API. So it's, one workflow I really like to see our customers employ is export your workspace, check it into source control next to, for example, your DDL files that kind of define the schema of your database. Then when developers go in and want to add, a new table or a new column, well, they're going to go do that. They're going to change the DDL file. They're going to create a PR or a code review or a pull request or whatever. And then, the person reviewing the code can say, hey, I see you've added this new column to this table. Well, I don't see a corresponding change in the Tonic workspace configuration that adds the generator that would be needed. And in that way, you can kind of keep everything really in sync with each other. And for CI/CD, you can just, pull those workspace configs directly from GitHub. You're about to release a new version. You go to the commit representing that version. You pull that workspace config. You load it into Tonic. You run Tonic, etc.
Awesome. We also have a comment in the chat that I think speaks to all this. CDC with autoloader with Tonic SDK. Do you know how to interpret that?
Okay. It's CDC. So CDC is, I think, typically it stands for change data capture. Okay. What's the next thing?
With autoloader.
I don't know what autoloader is.
Okay. With Tonic SDK.
Oh man, I need a more well-formed question to answer that.
Okay.
I'm not sure what you're getting at.
I wasn't sure if it was like a suggestion based on what we're saying.
I think what they're kind of getting at is if you want to do everything in more of a streaming fashion, like change data capture is a reasonable way to do it. And yes, if you're already running Spark or Databricks jobs that are like some element of change data capture, just like working on just incoming changes, then applying the Tonic Java SDK on top of that is a very reasonable thing to do.
Okay, and I just realized we launched into questions and I haven't even let you finish your demo, but I have one more for you that I think you've touched on.
Yeah, sure.
Bit. Just want to make sure it's fully answered. What format is the output data?
It depends on the format of the input data. So, I showed everyone that checkbox you can click that'll write everything to Delta. Well, if you do that, I think the answer is obvious. It's Delta. Otherwise, there are exceptions here, but we typically try to preserve the file type of the source tables or of the source tables. So if the source table is backed by Parquet, we definitely write back to Parquet. If it is like Avro or ORC files, we also preserve that. I believe for JSON, we actually don't preserve JSON. We write back to Parquet, but there's no reason we couldn't preserve the JSON, I think. And I'm not sure what we do for CSV files right now. I'd have to look into it.
Okay. All right. That's all the questions I got for you right now. If you want to jump back.
Sure. Yeah. So, I'm only going to point out a few things, and I think we can wrap this up. We have a lot of neat features that just make it easy to use this product, among teams and in large organizations. So I'll give you a few examples. One is schema changes. This is a very boring part of the demo because I didn't actually change the schema, but as the schema of the tables in your database change, you get alerts here. And these alerts can be configured to actually prevent data generations until they're acknowledged. So someone goes and adds a new column, we'll block out, disable that generate button until you go to this UI and acknowledge the alert. The goal being to prevent you from accidentally copying sensitive but untransformed data into your lower environments or to your de-identified data lakehouse. Additionally, we have some neat stuff around webhooks. So I can create a webhook, essentially that you can then, you can then use to kind of kick off the next step in your process. These webhooks can be configured to be fired when the job succeeds, failed, or is canceled. And I think this is a nice part of our experience. Additionally, two other things I'll discuss. One, I can share my workspace with others. And I didn't really get into this today, and I should have. But let's say, for example, I'm in the privacy page, okay? I get to this column country, okay? And I'm just not sure if it's actually sensitive or not. Security, time, this is USA. Need to flag it as sensitive. So I can go comment to security. If I've shared my workspace with the security at Tonic.ai alias, they'll be able to get an email notification if they've been left a comment. They'll be able to log into Tonic, and they'll be able to go straight to this view as either a let's pick someone else. Oh, I don't have any users. But if you share, you can actually assign different permission levels for these people, auditor, viewer, and editor. And depending on the security alias's permission level, then they can either leave a comment, or they can examine the data themselves, or they can apply their own transformation that they think is best. Okay, last thing to show are foreign keys. Now, foreign keys are kind of weird when you're talking about a data warehouse, right? Because data warehouses in general don't support foreign keys, or if they do, you can define them, but they don't actually do anything, right? So oftentimes, though, it's important to kind of know what the relationships are between tables. Imagine, for example, I have two tables, and then there is a pointer from one table to the other. It's not a foreign key constraint in the database system because those might not exist, but it's one that is assumed by applications and BI tools and users. And you might want to tell Tonic about that. And the reason you'd want to do that is so Tonic can preserve that relationship between the columns automatically for you. So you would go to the add foreign key column, and then you can simply tell Tonic where the foreign keys are. I'm not going to go through the experience, but this is a pretty good UI for adding foreign keys in bulk to databases. And once you've added these foreign keys, any changes or any transformations that you apply to the primary key column in those relationships will get automatically propagated down to all of the corresponding foreign keys to ensure that we maintain referential integrity in our de-identified output data set. I think that's it, Chiara. I've covered it all. And I know we've already covered a lot of questions, but if there's any more, I'd be happy to answer them now.
Funny, because right as you jumped into the foreign key, we got a question about foreign keys and preserving relationships and how whether Tonic has. I think you've already answered it. And it's can you see the Q&A, or would you like me to read through this just to make sure?
I can't see it because my laptop is now blocking the screen behind me.
Then I will ask this. Right. Given that Databricks is based on Spark and Delta tables don't have foreign key and primary key relationships of a traditional relational database, does Tonic have the ability to infer relationships between columns that are the same between various Delta tables and the data lakehouse to maintain the relationships in the de-identification process, or do you have to manually define all of those?
You have to manually define them, but once they're defined, we will preserve the relationships, as I already said. It is, in general, it is like really hard to properly infer foreign keys. I mean, when you think about it, right, like foreign keys oftentimes are integers. And like, okay, you have a primary key column. It's typically auto-incrementing. It starts at 1 and it starts going up, right? It goes from, 1 to 1,000,000 with some holes in it, right? Imagine all of the other columns in the database that are integer valued and have ranges between 1 and 1,000,000. How do you know which are foreign? How do you know which are foreign key and which aren't to that primary key column I'm talking about? So inferring can be really, really challenging. But if you tell Tonic about it, we will preserve it though.
And is there like the upload, the JSON file? Does that work with Databricks as well?
Yeah. If you if we go here, I mean, I actually don't know what this link has, but hopefully it has what I want. Let's see if there's an example of it here. Yes. So you can programmatically construct this file if you like, but as you're using our UI to build these foreign key relationships, it's all backed by this JSON structure here. You specify the foreign key schema, the foreign key table, the foreign key columns, and it's multiple columns, not one, in case it's like a compound foreign key. And then you do the same for the equivalent, primary key, which we call the target, right? And then, this is an array. You can have as many of these relationships as you like. So you can create this file yourself programmatically and actually just upload it to Tonic here if you wish. Alternatively, you can use our UI to build the relationships. It's up to you.
Perfect. Thank you.
Sure.
Another question for you as we come up on time. Is there a way to ensure consistency across workspaces?
Yes. So I should have said this, shame on me. Consistency works across workspaces. It works across tables in a workspace. It works across workspaces. It even works across database types. So if you're one of our customers today on the call and you're already using Tonic with your application database, and now the question is, okay, well, we're going to start using Tonic with Databricks, but we need the de-identified data lake to be consistent with our de-identified application database. That also works. Consistency can work across database types as well. And in fact, it does work, not can.
That's great. Thank you.
Great. Yeah.
And the last question that I currently see is, how does a system like Tonic work with data that has already been encrypted?
That's interesting. So it depends a lot on your setup, but I'll say this. It is very, very common for our customers to store encrypted data in columns. And I don't mean like transparent data encryption, like the database vendor handles it. I mean like the application encrypts the data before inserting it into the database. In that situation, like a few things can happen. And there's so many factors it depends on, right? Sometimes customers actually write an encrypted value in the column, and there's a corresponding column in the table, which is a hash of the original value, right? Because if you're doing proper encryption, if you encrypt the name Adam twice, you'll get 2 different ciphertexts, right? So you wouldn't be able to use consistency there because the ciphertexts are different. But if they have a corresponding hashed column, then you can actually use the hashed values to infer consistency, which can solve many of your problems. When that's not set up, though, oftentimes we'll need to decrypt the encrypted values. And we have a framework for doing that very quickly. Essentially, there's a questionnaire that we send the customers, asking them various questions about, what encryption technology they're using, what the scheme is for encrypting. If there is a need to access any keys to do decryption, which oftentimes there are, how do we do it? And then Tonic will actually provide to the customer's installation a plugin which will handle the decryption. And it all happens in a pretty, clean and transparent way to customers. It's very nice, and it takes almost no work on the customer's part, which is great.
And it all happens in their self-hosted instances.
That's right. And that's the thing I should have mentioned. Tonic offers Tonic Cloud, which is a way for you to use Tonic that we host for you. A lot of our customers, though, of course, are using our tool because they have very sensitive data that they don't want to share with others. For those customers, and this is true for a majority of our customers, they deploy Tonic on their own servers. It could be in their own data center, or it could be that they're running it in AWS or GCP or Azure, which would often be the case if you're talking about Databricks, because Databricks also runs in those public clouds, right? And for those customers that are running, on their servers, Tonic doesn't need to phone home. It can run entirely air-gapped if you wish it to, and it will never, under any circumstances, send your data back to us.
Perfect. Well, I think that's all the questions I'm seeing. If you have one last one, do feel free to drop it in the chat. But thank you all so much. Thanks to everyone who joined. Such a great turnout today. So many interesting questions. Adam, if you want to stop sharing your screen, I can just share one last screen. Let's see.
Sure.
Just so we got contact information.
Have I stopped sharing?
Yes, you have.
Great.
Yeah. So if you'd like to reach out to us, hello@tonic.ai. I'm sure Adam would be happy to get your emails as well. And we'll make sure he sees those. You can also reach out to me, Chiara@tonic.ai. We did just get a question. Will we receive a link of the recording via email to share? Yes, we will. We will be recording. The recording is being recorded, and it will be processed probably by sometime tomorrow. So you can expect to see an email with the link to the recording in your inbox tomorrow afternoonish, I'll say. All right. Thanks to everyone for joining. Thanks to all the great questions. And Adam, thank you so much for all of your insight and for showing that. That was a fantastic demo.
Oh, thank you so much.
All right. I will hope to see you all on the next webinar. We do have one coming up next week with our partner Makaru, and we'll be talking about data synthesis for data science use cases, which is a new topic that we are venturing into next week. Almost same time, same place, 10 a.m. instead of 11 a.m. That's
right. So bring your data scientists to this webinar next week. We're going to talk about very, very exciting ways on how Tonic can synthesize data. Entirely new, techniques under the hood that we use to generate data of such high statistical quality, you can use it for training machine learning algorithms. So stay tuned.
Yes. Awesome. You can just visit our webinars page on the website to sign up for that as well. All right. Thanks again, everyone. Great seeing everybody, and I'll see you next time.
Thank you.